You ever look at a skyscraper and wonder how it stays standing? These towering giants seem almost magical, defying gravity and weathering the elements, but there's no magic involved. Just a lot of engineering and some incredible materials, or a bridge stretching across a river. These structures connect us, making travel and trade possible, and they too rely on the same fundamental material. It's not magic, folks, it's cement. This unassuming powder is the unsung hero of modern construction. This stuff is the glue that holds concrete together, and concrete is what builds our world. From the foundations of our homes to the tallest skyscrapers, cement is the key ingredient. Without cement, we'd be living in a very different and probably much shorter world. Imagine cities without their iconic skylines or bridges that couldn't span the distances we need them to. Cement might look simple, just a fine powder, but getting there is a journey. It's a process that involves science, engineering, and a lot of hard work. It starts with digging up rocks, and let me tell you, not all rocks are created equal. The right kind of rock is essential for making high-quality cement. We're talking limestone, clay, shale, even iron ore. Each of these materials brings something unique to the mix, contributing to the strength and durability of the final product. These ingredients get dug out of the earth, and that's just the first step. The journey from raw material to finished product is long and complex. What comes next is a whole lot of crushing and grinding, mixing and baking. The raw materials are broken down into smaller pieces, then ground into a fine powder. It's a dirty job, no doubt, but somebody's got to do it. The workers in cement plants are the unsung heroes, toiling away to produce this essential material. And by the time we're done, those rocks are transformed into a powder that can hold an entire building together. This powder, when mixed with water, becomes the binding agent that makes concrete so strong. So stick with me and I'll break down the fascinating process of how cement is made. From the quarry to the construction site, we'll explore every step of this incredible journey. You'll gain a new appreciation for the material that literally holds our world together. All right, let's talk ingredients. Just like baking a cake, you need the right stuff to make good cement. But unlike a cake, the ingredients for cement are sourced from the earth in a much more complex and large-scale process. And the star of the show, limestone. This rock is the backbone of cement production. This sedimentary rock is chock full of calcium carbonate, the key ingredient that gives cement its strength. Without it, the cement wouldn't have the structural integrity needed for construction. But limestone ain't got all the answers. It's just one piece of the puzzle. We also need clay, shale, and sometimes even iron ore. These materials are crucial for adding different properties to the cement. These add different properties to the mix, making the cement smoother, stronger, or more resistant to the elements. For instance, clay helps in the binding process, while iron ore can add durability. Finding these ingredients means digging quarries and mines, some as big as small towns. These sites are meticulously planned and operated to extract the maximum amount of raw materials. These quarries are like open wounds in the earth, and the work is tough. The scale of these operations is massive, requiring a lot of manpower and machinery. Giant excavators and loaders scoop up tons of rock, working tirelessly to keep up with the demand for raw materials, while dump trucks haul it away in a never-ending stream. These trucks are the lifeline of the operation, constantly moving materials from the quarry to the processing plants. It's a dusty, noisy, and sometimes dangerous job, but these guys are the unsung heroes of the cement industry. They work in challenging conditions to ensure that the raw materials are available for cement production. Without them, we wouldn't have the raw materials to build a thing. Their hard work and dedication are the foundation upon which the entire construction industry stands. So next time you see a building, remember the journey of the raw materials that made it possible. So we've got mountains of rock, but you can't just mix those boulders with water and expect a sidewalk to appear. First, we gotta break them down to size. That's where the crushers come in. These machines are like giant metal jaws, chomping down on the rock and spitting out smaller chunks. We're talking serious crushing power here, enough to turn a car into scrap metal in seconds. The rocks go through multiple stages of crushing, getting smaller and smaller until they're about the size of gravel. But we're not done yet. Next up, we got to grind those rocks into powder. Giant ball mills, kind of like cement mixers on steroids, tumble the crushed rock with steel balls. The constant grinding action pulverizes the rock into a fine powder called raw meal. This is the stuff that eventually becomes cement, but first it needs a little chemical magic. Now, just like your grandma's secret cookie recipe, making cement requires the perfect blend of ingredients. But instead of sugar, flour, and chocolate chips, we're dealing with materials like limestone, clay, and a few other key components. The raw meal we just made gets mixed with other materials like sand, iron ore, and bauxite in precise proportions. Each ingredient plays a crucial role in the final product. Too much of one thing, and the cement won't set right. It might be too crumbly or too hard, making it unusable for construction. Too little of another and it won't be strong enough. The balance has to be just right to ensure the cement can withstand the test of time and the elements. This is where the science comes in. It's not just about mixing things together, it's about understanding the chemistry behind it. Technicians carefully analyze the chemical composition of the raw materials using advanced tools and techniques to get it just right, making sure the mix has the right balance of calcium, silica, alumina, and iron oxide. These elements are essential for the cement's strength and durability. It's like a giant chemistry experiment, but on a much larger scale. But instead of test tubes, we're using bulldozers and conveyor belts. The scale of operations is massive and precision is key. Once the mix is just right, it undergoes rigorous quality checks to ensure consistency. It gets blended together until it's completely uniform. This uniformity is crucial for the next stages of production. This blended raw meal is now ready for the next stage of the journey, the heating process, the fiery inferno of the preheater and calciner. Here, the raw meal is subjected to extremely high temperatures. Hold on tight, folks, things are about to get hot. The intense heat causes chemical reactions that transform the raw meal into clinker, the key ingredient in cement. This clinker is then cooled and ground into a fine powder, which is what we know as cement. The entire process is a delicate balance of art and science, ensuring that every batch of cement meets the highest standards of quality and performance. And there you have it, the recipe for cement. From raw materials to the final product, it's a journey of precision, expertise, and a bit of industrial magic. So next up we have the preheating and calcination stage. This is where the raw materials are heated to really high temperatures. The goal here is to drive off any remaining moisture and start the chemical reactions needed to form clinker. It's a critical step because it sets the foundation for the quality of the final cement product. Essentially, the materials are passed through a series of cyclones, which helps to preheat them using the hot gases from the kiln. This makes the process more energy efficient, which is always a good thing. Then the materials enter the calciner, where they are heated to around 800 to 900 degrees Celsius. At this temperature, the limestone decomposes into lime and carbon dioxide. This is a key part of the process, as it prepares the materials for the final stage of clinker formation in the kiln. All right, so now we move on to the transformation process. The raw mix is heated up to around 1450 degrees Celsius in a rotating kiln. This intense heat causes chemical reactions that form what we call clinker. Clinker is essentially small dark grey nodules, and it's the primary ingredient in cement. Next, these clinkers are allowed to cool down, and then they are ground into a fine powder. This is where gypsum is added. The gypsum helps control the setting time of the cement, making it workable for longer periods. The result is the fine grey powder we recognize as cement. Once the cement powder is ready, it's time for packaging. The cement is stored in large silos and then packed into bags or loaded into bulk transport vehicles. This ensures that the cement stays dry and is easy to transport. From here, it's delivered to construction sites around the world, ready to be used in building everything from homes to skyscrapers. Finally, quality control is crucial. Each batch of cement undergoes rigorous testing to ensure it meets industry standards. Tests for strength, setting time, and durability are just a few examples. This meticulous process guarantees that the cement is of the highest quality, ensuring safe and long-lasting construction.